Hello, we are back with 278, still in the 6th grade, this week focusing on expressions and equations. This is another lengthy standard that students participate in. So I just want to reiterate, I know I've said it time and time again though, that you have all year to go through all these standards. So although we're going through them pretty quickly and I'm assuming you know some knowledge, it's just to give you an idea again of the types of problems students are going to see, and then further using manipulatives to help them in visual models to make connections. And then here's some other ones as well. Algebraic expressions can represent both a recipe and a quantity, such as the sum of 3 and a number. So the word sum needs to add, and we want to add 3 and some number which we don't know. So since we don't know the number, what we'll do is just classify it as a variable because it can change. We don't know what that number is. Or less than a number. So we're having 4 and a number, but we want 4 that are less than or smaller than that number. So if our number is 10, 4 less than 10 would be 6. So what we're really doing is taking that number and subtracting 4 from it. So it's not always written mathematically as we read it verbally. The difference of 4 and a number. So I want to take 4 and a number and find their difference, which means subtraction. So 4 minus some number. These ones that we just talked about each have two terms, a number and a letter of sorts. The product of 5 and a number. So product means to multiply 5 and some number. So you can put it in parentheses or squish them together. This one though has two factors. Remember, factors are pieces that we are using when we're multiplying. The sum of 3 and the product of 2 and a number. The sum of 3 and the product of 2 and a number. So I really have two different parts here. I'm adding 3 and the product of 2 and a number. So the product of 2 and a number is written 2 times that number, and then I want to take the sum of that with 3. So 3 plus 2 and the number. Find the value of the expression when n is 5. So I'm going to stick where n is. I'm going to replace n with 5. So 3 plus 2 times 5 is 3 plus 10, which is 13. Heather has 4 more than twice as many marbles as Amber. Write an expression for the number of marbles Heather has. So Heather has 4 more than twice as many that Amber has. We don't know how many Amber has, but we do know that she has 4 more than. So twice as many marbles is written as 2x, and then 4 more than whatever she has, we add 4 more to it. So if Amber has 3 marbles, how many marbles does Heather have? So we will replace x with 3. 2 times 3 plus 4 is 6 plus 4, which is 10. So Heather has 10 marbles. Words can be used to write an algebraic expression, and we can find a numeric value for the expression if we know a specific value for the variable in the expression. Match each phrase to the expression described by the phrase. Take a moment to pause the video and see if you can't match them up appropriately. The sum of 2 and a number. So 2 plus n, which is letter D. 2 more than a number. That would be letter E. Whatever our number is, add 2 more. The difference of 4 and a number. That would be letter G. 4 less than a number is letter A. Whatever the number is, we want 4 less than whatever that number is. The product of 2 and the sum of 4 and a number. So the product of 4 and a number, when I look at letter F, is the 4 plus n, but I want to take the product of 2 and that portion. The sum of 2 and the product of 4 and a number. So the sum would be our addition. So when I look at letter H, 2 plus the product of 4 and a number. The product of 4 and the difference of a number and 2. That would be letter B. The product of 4 and the difference of 2 and a number. So it's written differently. Joey has 5 less than 3 times the number of pencils Samantha has. Write an expression for the number of pencils that Joey has. So he has 5 less than whatever Samantha has, and Samantha has 3 times x. How many terms does your expression have, and how many factors are in the first term of your expression? The expression has 2 terms because we're adding or subtracting 2 pieces together. And within that first term, 3x, there are 2 factors. Let's say Samantha has 3 pencils. Use your expression to find the number of pencils Joey has. We will plug in 3 or substitute 3 in for the variable. 3 times 3 is 9. Adding to 5 is 14. So Joey has 14 pencils. How many factors does the expression x plus y minus 3 times x minus y plus 4 have? Well, there's actually 2 pieces being multiplied here, so there are 2 factors in this expression. Each factor, though, has 3 terms in it. How many terms does the expression x plus 2y minus 4 have? Here, I have 3 pieces being added or subtracted, so there are 30 terms in the expression. A chef is getting the kitchen of her new restaurant ready for the restaurant's grand opening. Use your volume expression to decide which container is the best choice for each ingredient. Below, we have some ingredients and the amount that they need, or we have, and then we have some containers. These are rectangular prisms with a square base. So our volume is base times height. And remember, is base is length times width because we have a square. So when I look at my large container, we have 16 times 16, so width times length times height, so 20. This is the same as 16 squared times 20, and 16 squared is 256 times 20, so 5,120 centimeters cubed. The medium will be 10 times 10 times 20, or 10 squared times 20, which is 100 times 20, so 2,000 centimeters cubed. And then the small one is 8 times 8 times 20, or 8 squared times 20, giving us 64 times 20, so 1,280. Those that can fit into the large container are those that are closest to and over 2,000, so because they won't fit in the medium. So it looks like flour and sugar are both larger than 2,000, but not larger than 5,120. Rice looks like it'll fit in the medium container because it contains exactly 200 centimeters cubed. And then baking powder, salt, and cornstarch all are less than or equal to 1,280 centimeters cubed. So that'd be a good one for them. This rectangular prism has a length that is twice its width. If the width is x centimeters, what is the volume of the prism? So I have the prism labeled for us. So on one side I have x. On the other side we have twice whatever this side is. So we can still use our volume formula of the area of the base times the height. So the area of the base would be 2x times its height, which is 10. This is 2x squared times 10, which is 20x squared centimeters cubed. Write algebraic expressions to represent the number of pencils each student took and the number of pencils the student took altogether. How many pencils were in each pack? How many pencils did each student take? So student A said, I took 1 pack and 5 pencils. Student B said, I took 3 packs and 4 pencils. Student C said, I took 2 packs and 1 pencil. The teacher said, I started with 76 pencils. Let's start with student A. Since we are unsure how many are in each pack, we will call a pack X. So student A took 1 pack and 5 individual pencils. Student B took 3 packs, so 3 X's, and 4 pencils. Student 3 took 2 packs and 1 pencil. So the total pencils that are all together are adding the different expressions, x plus 5 plus 3x plus 4 plus 2x plus 1. Using my properties, I can grab all of the x's and put them together and all of my individual pencils and put them together. I see that 6 packs plus 10 extra pencils is how many we have. So let's see how close we can get to 76 pencils altogether. So let's say we start with 5. Do we have 5 packs? So 6 times 5 is 30, plus 10 is 40. Gotta go a little higher. Let's try 10. Let's say we had 10 packs. 6 times 10 plus 10. So 60 plus 10 is 70. Ooh, very close. So let's try 11. 6 times 11 plus 10 would give us 66 plus 10, so 76. We found our pencils, so there are 11 pencils in each pack. Let's go ahead and substitute 11 in for each X so we can determine how many pencils each student has. So 11 plus 5 is 16. 3 times 11 plus 4 gives us 33 plus 4, so 37 pencils. And student C had 2 times 11 plus 1, so 22 plus 1 for 23 pencils. The commutative and associative properties simplify variable expressions for us. Jocelyn, Ashley, and Cammie have some packages of candy and some single pieces of candy from open packets. Jocelyn has 2 whole packages and 8 other pieces. Ashley has 4 packages and 1 other piece, and Cammie has 3 packages and 7 pieces. Write and simplify an expression for the total number of candy pieces the 3 students have. So we don't know how many candies are in each package, so we will label them as X. Jocelyn then has 2 whole packages plus 8 other pieces. Ashley has 4 packages and 1 other piece, and Cammie has 3 other packages and 7 pieces. Altogether then, we have 2x plus 8 plus 4x plus 1 plus 3x plus 7. We can use the associative and commutative properties to rewrite all of the packages of candy together plus the individual pieces. So 2x plus 4x plus 3x gives us 9x, and 8 plus 1 plus 7 is 16. Let's start to see if we can't determine how many packages of candy we have. Let's start with 10. 9 times 10 plus 16 is 90 plus 16, which is 106. Not quite there yet, so let's try 11. 9 times 11 is 99, plus 16 is 115. All right, let's try 12. 9 times 12 plus 16 is 108 plus 16. We found our 124 pieces. So there are 12 pieces in each package. Let's determine how many pieces of candy each of the cousins have. So 2 times 12 is 24, plus 8 is 32. 4 times 12 plus 8 is 48 plus 8, so Ashley has 56 pieces. And Cammie has 3 times 12, or 36 plus 7, so 43 pieces of candy all together.